Yeah, so total number of defects initially was 250, and you want to go to 25, that means 110. So now you want this number, this of course is our target, and which of course you can see is 0.1. So what we want is 0.1 should be equal to e raised to minus beta 1t. Remember the formula for lambda, so lambda gets, or the formula for n is, I had it here. Remember I had this so you want this to be a 1/10. So you want this to be 1/10, e raised to minus beta t. And now you know the value of beta 1, so you can get the value of t, and the value of t that would fit. Okay, let me find it here. And the value of beta 1 we have found to be this 11.2 multiplied by 10 raised to minus 4 and multiplied by t. So we need to solve this equation for t. So take the log of both sides and do a little calculation, and it will turn out to be 2056 seconds of CPU time. And incidentally, sometimes you are asked to find out what would be the failure intensity at the time when you would stop, and you could calculate that also. So lambda at the time you will stop, and I'm calling it T1, is equal to beta 0, beta 1 multiplied by the exponent e raised to minus beta 1 t, and t is 2056, and you will find this to be 0.028 failures per second. Any questions or comments?
In the ratio over there, the n, t1, so why are we doing times 10?
Oh, this year?
Just before that, on the numerator and the denominator, we do 2.5 times 10, 25.
Oh, yeah, so this is the total number of defects. So this is the total number of defects at the beginning.
Okay.
Total number of defects at the beginning is 25 multiplied by 10, because there are 10,000. And at the end, we want defect density to be 2.5, and the size is, of course, still 10. So, yeah, we could have omitted that 10 there. Yeah, that was still. But just to show you what I was doing. Any questions or comments? Okay, now let me ask a question. Let us say that in your institution, you have been doing some testing before, so you know the value of beta 0 and beta 1 for previous projects. And Now let me ask this question, and this is somewhat interesting one. Let's say you had a previous project and the size was 5,000 lines per code. Beta 1 was 2 multiplied by 10 raised to minus 3 per second for your previous project. And then you have a new project which is 3 times bigger, 15,000 lines of code. Everything else is the same. What can you say about, okay, what can you say about beta 0? Same organization, same everything, except the project is 3 times bigger. So what can you say about beta 0?
3 times.
So beta 0, so you're saying that initial number of total defects will be 3 times. Right? That's, of course, a reasonable assumption. And that's what our expressions say also. But what about for beta 1? So we have a project which is 3 times as big. So what about, so is there, would there be a connection between this and this beta 1? And if you will look at the expression for beta 1 I had there, you will notice that beta 1 multiplied by S is a constant. Beta 1 is inversely proportional to size. So the new beta 1 would be equal to old beta 1, which is this, divided by 3 Now let me refresh your memory by showing you that expression once again. Remember this? S here is the software size, right? Okay, now let us look at the, so this is using the static approach. So you haven't been doing any testing, but based on your past experience, somehow you estimated values of beta 0 and beta 1 and made some projections. And now let us say you have actually started, you have done your development, and now you are doing testing. You have collected some test data, and now you want to decide when you will meet the target quality level. Then how would you do that? So how do you use sRGM during testing? Oh, I guess I haven't been keeping track of time. So I'm supposed to, okay. So how many of you have done a linear regression? Some kind of regression before, curve fitting. Now in Excel, you can do curve fitting using a couple of different ways. So for linear and for some of the, for some types of expressions, the regression, that means fitting, is built into Excel. So there is a lin-est function, and there's a log-est function, and then there is a way to do trend. So you have used the trend thing with Excel, right?
Yes, sir.
So will it allow you to fit an expression like this?
Yes. You just create the plot and just right click and add trend. You can select whether it's linear or exponential or log. It's easy.
I see. So I think we should be able to do this model with that built-in capability, right?
Oh, I have new to that. I mean,
So I think so. That there are a couple of different ways you can do it in Excel. So one way would be to convert the problem into a linear problem and do linear. And for linear, the expressions are you can just pick up the expressions anywhere, or you can use the built-in capabilities of Excel. So you have to do a regression that needs to do a curve fitting, you have to figure out how to do it. But if you have not done it before, it may take you some time to figure it out. But if you have done it before, it's probably very easy. Okay, so I think one of the questions that requires you to do some regression, right? Is that correct?
Yeah.
So you have to fit a curve. So, and when is the homework due?
Tomorrow.
Oh, okay. So you should have figured it out already. If not, then there's still time. Yeah. So if you are using SRTM during testing, then basically you have to collect data. Now let's see, tomorrow, why did I make it due tomorrow? Tomorrow is what, Friday?
Yeah.
So I suppose I could give you an extra date, so make it Saturday. So yeah, let's make it due Saturday. So take an extra day. So basically collect the data, and one common approach for software reliability modeling is to use grouped data. It does a kind of it is a sort of a form of smoothing. So rather than plotting the time for each individual defect found, you group the data into some groups, and let us say you take 8 or 10 or some number of defects, and find out for those defects what is the failure intensity. So this is a form of smoothing. Now you might think that smoothing is sort of like cheating when you smooth your data, but actually it is standard practice in statistics. A lot of times, if you don't smooth your data, there are too many short-term fluctuations that can cause problems with your analysis. Next is to select a model and determine parameters. So basically you select a model based on past experience. And I have found that in many cases, exponential or logarithmic would be a good choice. But if you are a Japanese organization, then they have a habit of collecting their data in a different way. So there are some S-shaped models that seem to fit the Japanese data well. So it depends on what has worked well